Firefox has been running on mobile devices for a while. We have a tablet interface, we have a phone interface. We're working on Firefox OS, which is going to be a new and exciting project. But for all of this development, we need to test it somewhere. And turns out you can test a lot of this sort of stuff on emulators. There are emulators that run on Linux that can emulate an Android system. But for performance and integration testing, we really needed to use some hardware. So we've been using NVIDIA Tegra boards for quite a while, and we're getting started using Panda boards. And this is what a Panda board looks like, for those of you who haven't seen them. Similar to a Raspberry Pi, same kind of project there. So we have a couple hundred of these now, about 800. These probably don't look like what's in your data center, right? There's no chassis here, there's no redundant power, there's one little wiggly power connector here. All of these are just soldered on, there's no real good attachments here. There's no active cooling. This misses everything you want in something you're putting in your data center. But we're putting 800 of them in our data centers, and we're going to do more soon. So we've also lost a lot of people time diagnosing these. Their SD cards go bad. We have to have someone go in there and try reflashing the SD card. That doesn't help. We try it again. It's a nightmare. So we need a tool to do a lot of this for us, and that tool is called Mozpool. We developed this over the last couple weeks. It's basically the requirements are that we have hardware on demand for various clients. So we have a build and test infrastructure that needs to be able to get a lot of Pandas and Tegras and things like that to run tests on every time we commit. We also have developers who need access to a board or a couple boards to do debugging or maybe do some relative performance measurements. We want to increase the reliability of these boards the way TCP increases the reliability of IP. So I want the outside interface to this to give people working hardware, when underneath we have hardware that sometimes works. We want to also do automated imaging and flashing. Firefox OS or boot to Gecko is a complete system, so we need to test a new version of it, we need to flash the SD card and put new data on there. We also need to do automated failure detection and remediation. So when these boards go bad, and I mean when and not if, it needs to figure that out, it needs to figure out exactly what went wrong and be able to say, these 17 boards need a new SD card, these two should get thrown out, this probably needs its connector wiggled. So this tool has 3 layers. The top layer is Mozpool, which is a little confusing to call the whole thing Mozpool in one layer. And that's essentially a cloud interface to this. It works sort of like Amazon EC2 requests do. I need a mobile board. It needs to have this image on it. It should be a Panda, or it should have this processor architecture. And maybe I want it in this rack or something like that. Mozpool finds a device that meets those criteria, puts that image on there if it can't find one that has that image already, and hands it off to the system that requested it. The next layer is Lifeguard, and Lifeguard handles the state of each of these hundreds and hundreds of devices using a state machine. So it knows what the process of reimaging is, and it can follow that along. If a particular step doesn't work, if right into the SD card doesn't work, retry, give a certain number of retries, and then it marks that board as bad, and a human goes in and does what needs to be done on that board. The bottom layer is Black Mobile Magic, or BMM for short. So we have, and I wish I could show you some visuals here, because they're kind of cool to look at. Jake's built these chassis that have 12 Pandas in them, and we have bunches and racks of these chassis. They have a relay board in them, so we can control the power to each of these devices remotely. This is as close as you get to out-of-band management of something like this. So BMM controls power to them. It has a system to pixie boot them into a live Ubuntu image, and that live Ubuntu image can run a bunch of shell scripts, and those shell scripts can do the Gecko install, they can do an Android install, they can do maintenance mode, they can do self-tests, and we can add to those pretty easily. So BMM is taking care of all those low-level details of doing stuff to boards. Lifeguard knows what's going on with the board and what should happen next and what to do if it doesn't, and then Mozpool talks to Lifeguard to find devices that are in the state it needs them to be in. So I have a tiny URL if you do want to look at these pictures, tinyurl.com/Mozpool, M-O-Z-P-O-O-L. We'll get you some nice pictures of our chassis. We have about 1,000 devices right now. We're going to be growing that pretty quickly, so this should be an interesting project to watch, but it's all very new right now, for a couple weeks. That's that.
Thank you very much.